So let's begin with number 2. And I hope we remember that to solve a system with substitution method, step 1 is to pick an equation and get a letter by itself. And there's many roads to the same place. Which one do you think is easier to pick, the top one or the bottom one? Top one. For sure the top one. Why? Because it already has y by itself, right? What is y according to this first equation? Y is 2x, okay? So here's y right here. What is y really? Y is 2x. So again, pick an equation. I pick the top one. Step 2 says substitute that variable expression into the equation you have not used. So we're going to plug it into the y right there. My bottom equation will read x plus 3y, but instead of y I put parentheses, equals negative 14. And I'm actually plugging in that 2x right into that y spot into the parenthesis. So now this becomes a regular one variable equation. There are no y's, it's just x's. So what I need to do is distribute, combine like terms, and then solve, right? So I am going to multiply 3 times 2x. That'll give me 6x, a positive 6x. I'm going to bring down the x that's in front. I'm going to bring down the equal sign and the minus 14. Now, I could combine this first x with that second 6x, right? That's what combining like terms is. My new equation will read 7x's equaling negative 14. And for my final step here to get x by itself, I want to get rid of the multiplication of 7 in front of the x. How do I get rid of multiplication? By doing the opposite division of 7. And what you do to one side, you must do to the other side. So we're going to divide by 7 over here. And we have our first answer, x equals negative 2. So we have an x answer, we need a y. Okay? So once you have one answer and you need the other, you always just plug it back in and solve for the other. And you could plug it back in either to the first one or to the second one. It doesn't really matter, but it does matter because the top one is a lot faster to do. It's easy to plug in a negative 2 right there where the x is at. 2 times negative 2 is negative 4, and I'm done. Y equals negative 4. But let me show my work here. I'm going to plug it into the top one. The top one reads y equals 2x. And again, I'm going to rewrite that y equals 2 parentheses because I'm actually going to plug in the x value of negative 2 right into those parentheses. So I really have y equals what? Y equals negative 4. Excellent. So we have the x value, we have the y value. How are we going to type in our answer? If this were a test, we're going to type it in as an ordered pair, the x value first and the y value second. So negative 2, negative 4. If I were to have graphed both of these, writing them in slope-intercept form and graphing them, we would see that they intersect at the location negative 2, negative 4. Okay, on number 4, step 1 is to pick an equation to be able to get a letter by itself. So if I pick the bottom one, I need to either get x or y by itself. But look at the top equation. It already has x by itself, right? So obviously pick that top equation because it already has x by itself. What does it say? It says x equals this junk right here, okay? X equals negative 4y. So what does x equal? It equals negative 4y. And what do you do with that x value of negative 4y? You plug it into the other equation you haven't used into the x spot. So my new equation right here is going to be 3 parentheses instead of x. And what am I plugging in there? I'm plugging in the negative 4y. And then you continue to write the rest of it, 2y equals 20. Okay, so you plug in the y value, or the x value of negative 4y. X equals that junk. Plug in that junk into x. There it is. Now do the math. What do I mean by do the math? Distributive property, multiplying, and then adding or subtracting. So 3 times negative 4y, that's negative 12y. And then bring down the plus 2y equals 20. And then combine your y values, the negative 2y and the positive 2y. When I combine those, what do I get? Negative 10y equaling 20. So for my final step, what do I do?
Divide by negative 10.
That's right, divide by negative 10. Thank you so much. And our final answer, or for the y at least, the final answer will be y equals what? Y equals negative 2. Okay? So we have one answer. We need the other answer. How do you do that? Plug it back in into any equation you want. It could be the first one, or it could be the second one. Now, of course, there's many roads to the same place. If I plug in a -2 for the y right here, I already know my answer is going to be +8. -4 times -2 is +8. That's my x value, and I'm done. If I wanted to choose the bottom equation, it's going to take longer. Plug in a -2 right there. 2 times -2 is -4. You're going to have to add 4, divide by 3 to get the same exact answer, 8. So obviously, the top one's easier to plug in. I'm going to show my work. X equals -4y. But instead of y, I'm going to put x equals -4 parenthesis, and I plug in that -2, giving us the x value of +8 as an answer. -4 times -2 is +8. So our answer for number 4, if you were taking a quiz or a test, it would be wise to type it in as a coordinate, and the coordinate is x first, y second, 8, -2. If you wanted to double check your answer, all you got to do is take both values, x and y, and plug them in to the x and to the y. Take x and y, plug it into the x and to the y, and see if it gives you a true statement on both, which it will. Number 6 is a little bit more entertaining. Step 1, pick an equation and get a letter by itself. Hector, which one would you pick on number 6? The top one or the bottom one? The top one. Why the top one instead of the bottom one? Because it already has the x by itself. Perfect, right? So we're going to pick the top equation. It already has x by itself. And what does it say? It says x equals this junk right here, right? So where am I going to put that junk? Into the x of the other equation. Why into the x? Because it says x equals that stuff. Here's x. X equals that stuff. I want to take that stuff and put it right here in place of x. Why? Because x equals that stuff, right? So here we go. The y minus 7 is going to go right in here. And I'm going to put in parentheses, y minus 7. And then I have the rest of the bottom equation, the +8y, the equal sign, and the 2. Okay? Now, even though we put it in parentheses, there's nothing to distribute. There's no 5 out here. Like if it would have been a 5x, I'd have to distribute 5 times y, 5 times 7. But there is no 5 right here. There's nothing out here. So there's really nothing to distribute. So I don't even really need those parentheses, right? So what do I really have here? I have y minus 7 plus 8y equals 2. And out of these 3 terms right here, I could combine the y's with the y's. So what is 1y plus 8y? Yep, 9y. Okay, so we have 9y minus 7 equals 2. I'm almost done. I need 2 more steps. How do I get rid of what do I get rid of to get y by itself? You add 7. Okay, so we're going to add 7 here, add 7 there. My new equation, I want to write it up here in green. Actually in black. My new equation will be 9y, the 7's canceled out, equals 2 plus 7 is 9. For my final step, what do? Divide by 9, and I'll have y equals 1. Okay, so I have one answer. I still need the other answer. How do I find the other answer? Plug it back in. Into which one? Any one you want. Top one. Okay, so the top one, I'm going to rewrite it. Top one says x equals y minus 7. But we already know what y is. Y is 1, so I'm just going to plug it right in there. So instead of x equaling y minus 7, I'm just going to plug in the y value of 1. So I really have 1 minus 7, right? You don't even need the parentheses. You're not multiplying by anything. So 1 minus 7 is -6. So x equals -6. So our answer, ordered pair answer, is -6, 1. Number 8, we have y equals 3x plus 8, 5x plus 2y equals 5. And since we're doing substitution, step 1 of substitution is to pick an equation and to get a letter by itself. So obviously, the top one's the better one to pick. Why?
Because it has y in it.
Because y is by itself, right? So if you had x by itself, pick that one with the x by itself. But right here you have y by itself. We're going to pick this one that has y by itself. It says y equals this stuff right here, 3x plus 8. So that 3x plus 8, which is really equal to y, I'm going to plug it into the other equation into the y position right there. Why am I plugging it into the y? Because it says y equals. So that's why I'm plugging it into y. If it would have said x equals, I'd be plugging it into x. So I'm plugging it into y. I'm going to rewrite the bottom equation, 5x plus 2y equals 5. Now instead of y I put parentheses. That's because I'm actually plugging in what y equals, which is 3x plus 8. 3x plus 8 is going right in there. Okay. So now we need to solve this thing, right? How do you do that? You simplify, you distribute, you combine like terms, and then you get the letter by itself. So I am going to distribute the 2 times 3x, that's 6x, 2 times 8, that is 16. Then you bring down the 5x that's in front, and that is a positive 6x, so put a plus in front of it. And we also have the equals and the 5. So out of these 3 terms, I could combine the x's with the x's. So 5 plus 6 really is 11 of those x's. When I combine 5x and 6x, I get 11 x's. Bring down the plus 16, bring down the equal sign and the 5. Now we want to get x by itself, so we get rid of the 16 first by doing the opposite of adding 16, which is subtracting 16. What you do to one side, you do to the other side. You will have 11x equaling negative 11. So for our final step, we divide by 11, giving us a final answer, x equals of negative 1. X equals negative 1 is one of the answers. We need both an x and a y. So far we have the x being negative 1. And what I'm going to do is take that x value of negative 1 and plug it in to the top equation, into the x, because after all it says x equals negative 1. So we're plugging in negative 1 right there. So on the side, I'm going to rewrite it as y equals 3x plus 8, but I put parentheses instead of x because I'm plugging in the negative 1 right in there. Doing the math, 3 times negative 1 is negative 3. Negative 3 plus 8 equals 5. And of course, the equal sign comes down. Whoops. The equal sign comes down and the y, so y equals 5. So if we're not too certain about this answer, we could double check it by plugging in our values. So if we plug in a 1 for x and a 5, so let me actually show, well, first of all, the answer, according to the work I just did, which I may have made a mistake, is negative 1 comma 5. So if we plug in the negative 1 for x on the top equation reads y equals, but instead of y, it's a 5. And then 3 times x, 3 times negative 1, and then plus 8. That's the top equation. That is correct because that's negative 3. Negative 3 plus 8 is 5. The bottom equation is 5 times x, and we know x is negative 1, plus 2y plus 2y. Y is 5. Does it equal 5? And the answer is yes, because that's negative 5, that's 10. Negative 5 plus 10 really is 5. So we've double checked it. We're absolutely positive that this is the correct answer. Okay. So on this one, which one would be easier to pick, the top one or the bottom one?
The top one.
Top one. Why? Because the y is already by itself.
So it's 4x plus 3 parentheses, right?
That value is going to go right into the y spot. Why the y? Because it says y equals. If it would say x equals, it'd be going over here into the x, but it says y equals, so it goes right into the y. So again, rewrite everything on that bottom equation. Let me zoom in because there's not enough space here. I'm going to rewrite this thing as 4x plus 3, but instead of y, I'm putting some pretty big parentheses to plug in the 5x minus 8. And you still have the equals and the 33. So we need to solve this nasty looking equation by distributing and combining like terms. So we're going to distribute 3 times 5, 15 with an x, 3 times negative 8, negative 24. That was a positive 15x. Bring down the 4x that's in front. Bring down the equal sign. Bring down the 33. And now we're going to combine like terms on the left side. I have 4x plus 15x. I could combine those to get 19x. So we're going to have 19x minus 24 equaling 33. And those are big numbers. Let's start getting x by itself. What do I get rid of first?
Plus minus 24.
The minus 24 by plus 24, that's right. What you do to one side, do to the other side. I will have 19x equaling 57. Now, you might not know this, but you could use a calculator to get rid of the multiplication of 19, divide by 19, and that will be 3, okay, with the calculator. Okay. So x equals 3 is one answer. We need the other answer, the y value. I'm going to plug in the 3, the value of 3 for x. I'm going to plug it in right there into the top equation. You could do the bottom, but this one's easier. If I plug in a 3, you could even do it in your head. 5 times 3?
15.
15 take away 8? 15 take away 8? Okay, 7, right? So the answer is y equals 7. But let me actually show my work here. Y equals 5 times x minus 8. Plug in this 3 right there. That's 15 minus 8. That'll be 7. So y equals 7, right? The equal sign comes down, the y comes down, y equals 7. So your answer is the ordered pair 3, 7. So when you have an equation that is already set up, y equals or x equals, that's the equation that you want to pick to be able to substitute into the other equation. This is called the substitution method. Now, not all of them are going to be like that. Sometimes, like on number 12, it doesn't have the x by itself or the y by itself, but you could pick which one's easier to do. Which one do you think's easier to pick, the top one or the bottom one? That's it. Yeah, well, the top one, because all you need to do is get rid of this 5y, and you'll have x by itself. Right? If you pick the bottom one and you wanted to get x by itself, you'd have to get rid of the y and then divide everything by 3. Right here, to get the x by itself, all you got to do is get rid of this plus 5y by subtracting 5y. So that top equation, I'm going to rewrite it to be x equals, I'm going to write the minus 5y first and the plus 4 second. Minus 5y first and the plus 4 second. So this is what x really equals. It equals negative 5y plus 4. Well, the variable expression, that is. I want to take that variable expression, that x equals, and plug it into the equation I have not used. I'm going to plug it into the bottom equation, into the x position, because it says x equals. I chose to get x by itself. It says x equals that stuff. I plug in that stuff for x. So now I'm going to rewrite the bottom equation, but instead of 3 times x, I want to write it 3 times negative 5y plus 4. And I still have the plus 15y. I still have the equal sign. I still have the minus 1. All I need to do now is distribute. 3 times negative 5y is negative 15y. 3 times 4 is 12. Bring down the plus 15y. Bring down the equal sign and the minus 1. I'm still simplifying the left side. I've already distributed. Now I need to combine like terms. This negative 15y could be combined with this positive 15y. They cancel out. What do I have left? I have 12 equals negative 1.
It's not true in any universe.
That's impossible in any universe. That's no solution. No solution. Visually, if you were to graph those lines, they would be parallel. They would not cross. Okay? So on number 14, if we want to use the substitution method, we're going to have to first pick an equation and get a variable to be by itself. So which equation do you think is the best to pick, the top or the bottom? Top, because you have a single x here, and you could get that single x by itself by simply subtracting 4y and subtracting 4y. So step 1 on substitution is to pick an equation and get that variable x by itself, or the variable y, whichever one you choose. In this case, we're getting x by itself. So my new equation up on top will be x by itself equals, this cancels out. We end up with 8 minus 4y, but I'm going to write it backwards, minus 4y plus 8. Minus 4y plus 8, okay? So that's the top equation with the x variable isolated. Now, step 2 on substitution is to take this variable expression, not the whole equation, but just the variable expression part, the x equals the negative 4y plus 8. You take that negative 4y plus 8 and you plug it into the equation you have not used into the x. Why x? Because we solved for x. It says x equals this stuff. So I'm going to plug in that stuff right where x is at. Again, because it says x equals, I'm going to plug it right into x. If it would have said y equals, if I would have chose to solve for y, then it would say y equals and I'd plug it into y. But because it says x equals, I'm plugging it into x. So rewriting my bottom equation on number 14, I'd have 2 times parenthesis, and in that parenthesis, instead of x, I'm going to put the minus 4y plus 8. And of course, I still have the minus 5y, and I still have the equals and the 29, but this is my new equation that I must solve. So I plug in the variable expression, and then I solve it. When I solve, I distribute 2 times negative 4y, that's negative 8y, 2 times 8, that's 16. Bring down the minus 5y, bring down the equal sign and the 29. Out of these 3 terms, I could combine the y's. I could combine the negative 8y and the negative 5y, and when I combine those, that'll give me a negative 14y. No, negative 13y. And of course, we're going to bring down everything else. We still have a 16, so bring down the plus 16, bring down the equal sign, bring down the 29. We almost have y by itself. All I need to do is get rid of the 16 by subtracting 16, subtracting 16. My new equation will be a negative 13y, this cancels out, equals 29, take away 16, that is 13 itself. So I really have negative 13 times y equals 13, so I divide by negative 13, divide by negative 13, and I will have my first answer, y equals negative 1. Okay? Now, for my other answer, anytime you have one answer and you need the other answer, just take your answer and plug it back in to any of the original and solve. So we could plug it into the top one or to the bottom one, and we're going to specifically be plugging into y because it says y equals negative 1. I want to go to the top one. I want to plug in the negative 1 right there where y is at. So I'm going to rewrite the top equation. It's going to read x plus 4 times that y value of negative 1 that I'm plugging in right there, negative 1. And of course it still says equals 8, so I write that down, equals 8. And when I multiply 4 times negative 1, that'll be a negative 4. Bring down the equals 8, bring down the x. So I really have x minus 4 equals 8. For my final step, I'm going to add 4 and add 4, giving us x equals 8 plus 4 is 12. So according to me, right now, my answer for this system is the coordinate 12, comma, negative 1. You write your x term first, your y term second. According to me, if I were to graph these, they would intersect at the location 12 on the 12 and negative 1. Okay, now what if I weren't too sure about all this work? What if I'm doubting myself? What if I think I made a mistake? What could I do?
Plug it in.
I could plug it in. I could take the 12 and plug it in for x, take the negative 1, plug it in for y. So 12, 4 times negative 1 is negative 4. 12 minus 4, it really is 8. It checks off on the top equation. If I take the 12 and put it there and the negative 1 and put it there, negative 1 times 5 is positive 5. And 2 times, that was a 12. 2 times 12 is 24. 24 plus 5, because a negative 5 times negative 1 is positive 5. 24 plus 5 is 29. So I've double checked it, both equations. I'm absolutely positive that's the correct answer. This video is getting long, so I want to stop right here. But before I stop, I want to explain that we are going to learn another method, which is called linear combinations method, and that will help us out. It'll give us a third option, which is even better. It's the best method, actually, I would say. When they're lined up, linear combinations method or elimination method is the best. And we're actually going to make another video later explaining that. And we could even apply the elimination method on these other questions that we have here.